Dear colleague, respected auditoria, my name is Aleksandar Pjević. I represent the company Lindab, Swedish company Lindab, permanently working in Moscow, Russian Federation. I remember that Professor Todorovich was counting students from many towns over our beautiful land, and now I will use the opportunity to prolong counting and to ask auditoria, for example, is there someone from Slovenia? Slovenia, hands up. Thanks a lot. Is there someone from Russian Federation, from Moscow? Moscow? Okay. Also, I'm going to use opportunity to make welcome from a colleague from Moscow. It will be special welcome. Уважаемые коллеги, добро пожаловать вас в наш прекрасный город Белград, Сербию. Надеюсь, что у вас тут будет приятное времяпровождение и что будете создавать новые контакты и получить удовольствие от них. What concerns of English, of course, Professor Todorovich emphasized that it's very important for engineers to possess knowledge, to be fluent, but from my position, being I work in Russian Federation for 12 years, I assure you, respected students, that Russian language also has a great, is very perspective. Just because of that, Russian market is in rapid and constant development. What concerns of my subjects, it's related on swimming pool objects. This is the index on the first sentence is importance of correct designing of air ventilation systems in swimming pools. After that, main characteristics of swimming pools designing, conception of air distribution. We are going to see some related realized projects, CFD analysis of air parameters on real case, something about air handling units, and finally LCCA analysis and comparing of different types, conceptions of air drying by means of air handling units. This slide shows the great responsibility of designers of swimming pools. Object was located in Moscow. It was deterioration of outside wall just because of incorrect designing. These photos indicate our responsibility in projecting of such objects. Unfortunately, there were casualties. Main characteristics, there are several swimming pools, type of swimming pools. Individual swimming pools are built according to individual projects, and there are some special characteristics. Usually the area of water surface not more than 50 square meters. They are located in a one-store building with height up to 6 meters, not more, with water heating around the perimeter and significant glazing outside wall. Mode of operation and exploitation are short time, episodic. What concerns of recommendation for air distribution, primarily humid air, as easier, is withdrawn from the upper zone of the object, and the using of displacement ventilation can be considered. Another type of swimming pools are hotel swimming pools, and there is a great difference in comparing with previous. First of all, it's extended period of exploitation, and it's necessary to pay attention that there are no sport applications. Consequently, the main task is to create maximal comforts for individual. And after that, public swimming pools, high humidity and presence of aggressive chemicals, its main characteristic, huge dimensions of project, part of exterior walls has a glazing. Of course, it must be provided comfort conditions of residence, and attendance of objects can be rapidly changed. This is input, and there are main tasks for designers: the protection of building construction and achieving of requested humidity in the room, selection of air distribution elements with long throw and great airflow range, the selection of heating and ventilation elements for adequate air changes and preventing of condensation, achieving of high quality air in space by means of swimming pools air handling units, and in our practice it's necessary to project optimal and energetically efficient BMS. The problem of swimming pool humidity relates because there is great quantity of water that vaporizes from the water area, and it can be from 0.1 to 0.2 kilograms of water from 1 square meter per hour. But in the case of water attractions, wave forming, vaporization from the water area can be increased to 2.0 kilogram per square meter an hour. Vaporized water condenses on outside wall, and if the climate conditions are very severe and cold outdoor, it can be bring to the deterioration of construction. Also, consequences are the next: generation of mold, metal construction corrosion and degradation of air quality in the space. Primarily, in most cases, we encounter next input parameters of inside air 30 degrees of Celsius, 55% of relative humidity, absolute air humidity not more than 15.5 grams per kilogram, and water temperature 28 degrees of Celsius. Request for comfort conditions, air distribution elements. There are some recommendations, for example, from the standard VDI 2089. Recommendations is to direct supply air in the lower zone of the space around perimeter, and air exhaust from space is better to organize from the upper zone. Air humidity in the space should be in range from 40 to 70%. Very low humidity increase energy consumptions and negatively affects on visitors' comfort. Some of realized projects in Moscow, suburban Moscow, for example, floor convectors on outside wall supply air from slat diffusers. The air passes over the water area, and this is the opposite wall when, by means of slot diffusers, air exhausts. The another one, also Russian Federation, the town Ufa, air supply is by means of nozzles from the great height. Heat energy is transmitted by means of 4 convectors. Another one is aquapark in Minsk, Belarus. For example, nozzles and diffusers in the center of the room. CFD analysis for that object committed by Lindab, EMP KLIMA. The task from designer of whole project was to check possibility for generation of condensation on the glazing. Input parameters were the next: airflow in variable quantities, supply air 40 degrees, air temperature in space 31 degrees, relative humidity in space 54%, and temperature in Minsk outside air minus 24 degrees. For input, after that there are variation in airflow and also in temperature, and we can see on this slide disposition of air temperature 40 degrees on the floor, and temperature decreases up to the height of the building. Also disposition of air velocity. And conclusion, there is potential danger of condensate generation beginning from the 10 meters from the floor, and just because of that, after this calculation, was our proposal to designers to rearrange air distribution on the object. It means that on the floor, the solution with floor diffusers exists, and after that we added air distribution by means of nozzles. Now we were obliged to check another conditions. First of all, to see the air throw of the air, if the distribution is by means of the nozzles. This slide shows and demonstrates that we could decrease supply air temperature from 40 to 35 degrees of Celsius just because of good rearrangement and air distribution. Calculation has been done by means of program Lindab EMP KLIMA, and after that all selection from that we received from this program was checked by means of CFD analysis. There were variation between angle of air distribution and also the airflow. We have got results that convinced designers to use such solution for air distribution. One more time, floor diffusers on the floor and nozzles from the top. What concerns of air handling units, they are special design just because of great humidity, just because of chloramines. Mode of functioning are demonstrated on this slide. For example, upper and left, air heating in water heater in night mode without moisture elimination. The second one, air drying from the space by means of cooling in recuperator and evaporator of heat pump. Third one, during the exploitation, it's obliged to supply fresh air according to norms. And another one, air drying on middle temperatures of outside air with or without heat pump using. There are some modifications. For example, if we want to warm up water in swimming pool, it can be done by means of this composition of air handling units. And finally, LCC analysis, life cycle cost, example of calculations, input parameters, 20,000 cubics of the air per hour, free composition. This is the first one, the full air handling units with recuperator and heat pump, evaporator, compressor, condenser. On diagrams are presented all conditions of air. The table demonstrates the condition of air calculated by means of software. The second one is the same, but the only difference is there is no heat pump. The third one, simplest is only with mixing of the outside air without energy recuperation, without heat pump, and it's time to say that this composition is 3 times cheaper than the first one. But in exploitations, it's much more expensive solution. Why? Just because of that there is green zone and it shows so much heat energy consumes in order to achieve the same conditions. To the left is consumption during the 15 years of the first air handling units, and it can be noticed that there is so many consumption of electric energy, red zone, but it was compensated with the huge expenses for heat energy. This is all from my side. Thanks a lot for your attention.
Thank you very much.